Hi, in this video, I will be showing you problem number 7 of chapter 14, section 8. The extreme value problem has a solution with both maximum value and a minimum value. Use Lagrange multipliers to find the extreme values of the function subject to the given constraint. f of xyz equal to 10x plus 10y plus 4z, and the constraint is 5x square plus 5y square plus 4z square equal to 44. The question is asking us to find the extreme values, which are absolute maximum and absolute minimum. So in this case, we are going to use the Lagrange equations. A gradient f equal to lambda times gradient g, that is equation 1. Then equation 2 would be the constraint 1. In this case, constraint is g of x, y, z equal to 5x square plus 5y square plus 4z square equal to 44. That is equation 2. Now let's consider equation 1. Del f, gradient f equal to lambda times gradient g, which means it will be f sub x, f sub y, f sub z equal to lambda times g sub x, g sub y, g sub z, partial derivative with respect to x, y and z. So partial derivative with respect to x would be 10 because it's 10x plus 10y plus 4z. If you differentiate f of xyz with respect to x partially, it will be 10. Then f sub y would be 10, f sub z would be 4, and this is equal to lambda times g sub x, which is from this relation, that is 10x, then 10y, g sub z equal to 8z. By comparing the corresponding components, 10 equal to 10 lambda x, 10 equal to 10 lambda y, then 4 equal to 8 lambda z. That way we would get x equal to 10 over 10 lambda, or that will be 1 over lambda, y equal to again 10 over 10 lambda, which is equal to 1 over lambda, then z equal to 4 over 8 lambda, which is equal to 1 over 2 lambda. So we get x, which is 1 over lambda, y, which is 1 over lambda, z, which is 1 over 2 lambda. Now we are going to use the constraint, which will be 5x square plus 5y square plus 4z square equal to 44. So if we substitute the values that we got in this step for x, y, z, we are going to have 5 times x square, that is 1 over lambda the whole square, plus 5y square, which is 1 over lambda the whole square again, 4z square, which is 1 over 2 lambda the whole square equal to 44. So this would give 5 over lambda square plus 5 over lambda square plus 4 over 2 lambda the whole square, that will give us 4 lambda square equal to 44. So this will be 1. So it will be 5 plus 5 plus 1. So 11 over lambda square equal to 44. If you cross multiply, 44 lambda square equal to 11. So lambda square equal to 11 over 44, which is 1 over 4. So taking square root, we get lambda equal to plus or minus 1/2. Now we have to determine the corresponding points using the relation 3, which is x equal to, in terms of lambda, So we are going to use that relation 3 to get xyz. So using relation 3 here in blue, x equal to 1 over lambda, which is 1 over 1 half, assuming lambda equal to 1 half, x equal to 2, y same thing 1 over lambda, which will be 1 over 1 half, that will be 2 again, z equal to 1 over 2 lambda, which is 1 over 2 times 1 half, which is equal to 1. So 1 point x, y, z equal to 2, 2, 1. Then we are going to use the other relation z, lambda equal to negative 1 half. We're going to use lambda equal to negative 1 half and get the corresponding x, y, z. X equal to 1 over lambda or 1 over negative 1 half, that will be a negative 2. Similarly, y equal to 1 over lambda equal to negative 1 half, that will be a negative 2. Z equal to 1 over 2 lambda. When you plug in lambda equal to negative 1 half, that will be a negative 1. So now the point xyz would be negative 2, negative 2, negative 1. So we get 2 points 2, 2, 1 and negative 2, negative 2, negative 1 where absolute max and minimum occur. So the extreme values, so if we consider f of the extreme values are absolute max and absolute min, f of 2, 2, 1 would be obtained by plugging into the original function of f. The original function of x is f of xyz is 10x plus 10y plus 4z. So we are going to plug it into that relation. 10x plus 10y plus 4z. So 10x plus 10y plus 4z. So if we use that, that will be 20 plus 20 plus 4, that is 44. Then the other one, f of negative 2, negative 2, negative 1. So 10 times negative 2 plus 10 times negative 2 plus 4 times negative 1, that will be negative 44. So this corresponds to absolute maximum, which is 44, which is attained at 2 to 1. This value, negative 44, corresponds to absolute minimum that occurs at negative 2, negative 2, negative 1. Hope this video helps.